What was the last thing that you had to do deep research on? Kate Soule is Director of Technical Product Management for Granite. Kate, welcome back to the show. What have you been researching?
I've been researching KV cache management.
Volkmar Uhlig is Vice President AI Infrastructure Portfolio Lead. Volkmar, welcome back to the show. What have you been looking into?
Indices and vector databases.
And last but not least is Shobhit Varshney, Senior Partner Consulting on AI for US, Canada, and Latin America. Shobhit, welcome to the show. What have you been looking into?
Quantum computing, especially how it intersects with AI.
All right, all that and more on today's Mixture of Experts. I'm Tim Hwang, and welcome to Mixture of Experts. Each week, MOE distills the biggest stories in the world of artificial intelligence and gets you what you need to know. As always, we have a lot to cover. We're going to talk a little bit about rumors on OpenAI's inference chip. We're going to talk about small vision models. We're going to talk about a job listing for an AI agent. But first, I really want to talk about deep research. And it's kind of a funny phrase to use because it seems like nowadays everybody has a feature called deep research. Google Gemini has a deep research function. ChatGPT announced a deep research feature. Even Perplexity announced a deep research feature. And not to be left out, Grok has also launched a feature as of late called deep search. And these are all kind of features where you can do a query to a model and get back what is effectively a very long research report that's kind of in depth. And, this all really literally happened, I think, in the last month, 2 months or so. I guess, Kate, maybe I'll start with you. Why is everybody suddenly launching a deep research feature? What are they trying to do? And why is it suddenly all very competitive? Why is deep research the new hot thing?
Yeah, so I think it's helpful to understand some of the broader context in when all of these features were released. So, back in January, DeepSeek came out with their R1 model demonstrating crazy reasoning capabilities. OpenAI, maybe in a bit of a response, a way to show that they're, also innovating on reasoning and doing a lot of work in the space, pretty much launched as a fast follow from what I've been able to tell their deep research capability, which leverages the O3 reasoning model behind the scenes. And I think ever since that model came out, we've been seeing a lot of following the market, and a lot of other companies come out and create their version too, just to try and follow that broader trend and focus on reasoning models that have really taken the world by storm.
Yeah, for sure. And Shobhit, maybe I'll bring you in here. One of the questions I have is how do you win in this competition? It's like we're suddenly living in a world where there's 4 or 5 search engines, and it's it's the early 2000s again. And it's kind of really a question about if you see any kind of differentiation between all the companies and how they're trying to win on this particular feature.
Yeah, so I think Google came out with this first in December, followed by OpenAI, and then followed by Perplexity, and now with Grok 3. The overall intention is, given a complex ask, I want you to go research this across a whole multitude of different websites. Then try to cluster them in different topics, and then when you find something, you go find other things that are relevant, just the way humans do this. Right? So you're trying to replicate the way a human would have otherwise open up 20 different browsers and try to simulate all of that into a topic and research, right? Now, when companies like Google are doing this, they have a really good understanding of how web pages are structured and how things semantically connected and so on and so forth. So most of these deep research models will start first by creating a plan. They understand your query and they'll have a plan generated. In case of Google, I can go and hit edit and I can go change the plan if I need to. In case of ChatGPT, it'll go ask you some follow-up questions. So you can go modify that and understand that here's how we're going to execute. There are certain queries that needs a little bit of disambiguation. Do you mean X versus Y? When I look for transformer, is that the movie or is that the model? Things of that nature. In certain cases, you may need to narrow the field a little bit and go very, very deep in a particular topic, right? So you're first establishing, here's the goals, and here's the research plan. That's what a good research analyst would have done for you. Then it fires off and starts to go crawl the web and starts to find all the websites that are relevant. Then extracts everything out of it and say, hey, I found that this particular website was talking about a new, for example, we were looking at quantum last night. Microsoft released a new model with some new matter altogether. So now all of a sudden you have a new topic that's coming up that I did not specify in my initial search. So that'll then spawn additional queries and so on and so forth. So it's going and crawling all of that, bringing all the content back. So your question was around how do you win in this? On the more B2C side, me as an end customer, the person who can connect the dots between the websites and the content the best is likely going to win. speed matters to an extent, whether it takes 3 minutes or 4 minutes. At the end of the day, I'm going to have to come back to this tab anyway. So I think I'm okay on the speed and the latency part. But understanding, grounding it, and being able to give the right citations. At least in my personal experience, using Perplexity, I've been using Pro for a while. Perplexity Pro Deep Research was a little more hallucinating than I'm getting with Gemini. And so far, OpenAI has been the best for at least my experience on the topics that I researched. But there'll be some nuances of how you ground your content, you get all the responses back, and then do visual interpretation of all those different websites. In the enterprise space, this is untapped right now. In an enterprise, when somebody gets a question saying, why was my claim denied? Or if I want to say, can I travel to X and what will be my ATM charge and what kind of benefits I have? There's a very unique set of documents that need to be looked at, where a human researcher goes and looks at multiple systems. It's a combination of actually logging into a third-party SaaS, figuring out information there, reading some documents, so on and so forth. We have not quite crossed the chasm yet on deep research coming to the enterprise space. I don't see a single vendor out there that's enabling us to go add enterprise data to it, be able to model how the reasoning steps work based on the topic at hand. I think 2025, towards the end, we'll start to see these models getting more open. There should be other layers on top that bring it into the enterprise space. I think that's the company that's going to make billions of dollars versus somebody who's doing a B2C view.
Yeah, I mean, I think that's kind of the interesting thing is like, I feel like the use cases that I've seen online so far have been people who have pretty niche needs, right? Like, I think it's like, researchers or kind of bloggers that need, studies. Volkmar, maybe I'll bring you in. I feel like over the last few episodes, you've increasingly become like the loud skeptic on the MOE expert panel. Are you kind of impressed by stuff like deep research? Do you use it at all? Like, it does feel to me that there's a bunch of problems. And I guess the question is like, also whether or not it's like technically that impressive either. It's like kind of a just combination of existing components. Is that the right way of thinking about it?
I think it's a really interesting approach. I think it's incremental. We already had the ability to search. Now what we are doing is, we are just extending the search, scope. I think we already had the first iteration of, go out, make a plan. Now I think do longer reasoning straight out of the model. I think what's changing now is that we are saying, we go multi-step reasoning and multi-step document retrieval and extending, the knowledge. I think the larger context window sizes allow it to do that. So that was one of the things which, if you just have a 4K context window, you cannot do that. If you now have, 128K, you can throw lots and lots of documents at it and you can start reasoning about it. So I think we are at this junction that the data is available. So, I mean, this is also the other thing, right? So OpenAI started having, a crawl of the internet accessible in a vector database. So you needed search capabilities, you needed the long context window sizes, and you need to have the multi-step reasoning. And so all these things now are at a point where they are individually stable. And now we are getting into, okay, what can I build out of this? So I think it's a really interesting application. And it, I think, shows the direction where we are heading, right? It's like multi-minute, processing with answers. I think it also shows that we are at a point that the models, we are willing to not just babysit the models every, 100 characters, but we are letting it run for a while. And the quality of the models is high enough that they don't just go off into a tangent.
Totally. Yeah. It does feel like that's kind of like almost like the biggest thing is like less a technical thing and more just like a sociological thing is that like we just now have enough trust in these systems that we're willing to let them run like this, which is like pretty interesting.
So Tim, on one of the challenges you see in deep research is you don't have a verifiable output to compare accuracy against. And we struggle with this even in organizations. So when you come back with a deep document on, say, I'm looking at what are the milk regulations in Europe versus India versus the US, right? I don't know what good looks like, so it's difficult for you to verify the output. And a lot of these companies are struggling with the evaluations around these deep research files, right? There's some things that I can calculate, like how many paths did you create, how long did you think, how many websites did you hit, and so on and so forth. But there's not a good measure, even in our real world. If I hire two different research companies to go research a particular topic, they will come back with different documents, but I won't have a good validation routine around that. So I think it's an order of magnitude tougher problem than, say, you are trying to write code or do some math where I can deterministically tell you whether the answer is correct or not.
Yeah, no, I think it's like very complicated. And I think the evals question on this is like very hard. It's like, how do you do good benchmarks on this kind of feature? Becomes like very quick tricky. Yeah, maybe a final question, Kate, maybe I'll turn to you, is out of the 4 companies we have here, we have Google and OpenAI, right? Giants, titans of the space. We have Perplexity, who has really spent a lot of time working on search, so it's no surprise that they would do this. What's kind of interesting here is Grok, which really has only hit the scene fairly recently, and is as yet kind of launching these features that are very much kind of at parity. And I don't know how you read that. I mean, there's one point of view, which is, well, the space is more competitive than ever. Anyone can just kind of get in and launch these cutting edge features. I think there's also a view which is, well, Grok is just executing in an incredible way. But curious how you read that. Is it easier and easier to launch some of these state-of-the-art features with teams that are way smaller? It's still one of the questions I have.
We're benefiting from having so much of the innovation starting to be put into the open source, which is allowing a rising tide to float all boats. It's allowing less traditional players to enter the market. And we're seeing just a really rich ecosystem emerge from it. So it's exciting to see what Grok and others can come out with. And as we talk about deep search and how that relates and deep research, again, I really think right now deep research is one of the more practical use cases for reasoning. If we're all innovating on reasoning and we're seeing a lot of that work in the open source, a lot of the benchmarks are on math. Like, I don't know that is the killer use case that, is why I pay for a bunch of reasoning tokens. But research is certainly an area where we're seeing some benefit. And, I think this is just one of those early use cases that we've identified where there's some clear demonstrable value that the reasoning's bringing. And so that's why we're seeing as new models come out, they're also coming out in parallel with a deep research type of capability.
Well, I want to move us on to our next topic. It's a story that I feel like we do every few episodes, to be totally honest with you, which is every few weeks or months, there's always rumors that OpenAI is working on its own chip. And the story this time was kind of a leak that, OpenAI was kind of readying sort of an inference design with TSMC, which is kind of one of the lead kind of chip fabs. And I think I wanted to kind of use it as a hook to talk a little bit and check in, I think, on sort of the state of like OpenAI's competition in the hardware space. And, Volkmar, I guess you're the natural person to turn to for this sort of thing. It's sort of interesting to me that at least what has been reported in the news is that OpenAI is investing first in inference chips. And I guess for our listeners, do you want to explain just like why this would be such a big priority for them? Because this is a very big bet they want to make. And I guess the question is like what you believe their upside to be in investing in this sort of thing versus using, the established companies that are out there.
OpenAI is building the chip not by themselves, right? They are partnering with Broadcom. And Broadcom is one of the giants in chip manufacturing. So that's an expected. I mean, they had to pick a partner if they don't want to become a chip company. And I don't feel that OpenAI, wants to get into that market as a primary business model. Now, if you look at training versus inferencing, the requirements are very different. So in training, if you build a training cluster, it's a lot about, you have the basic GPUs, but then a good chunk of the money goes into the networking infrastructure and goes into the storage system and having, effectively a high performance computing system. So it's like if you look where all the HPC people went, they all went into AI now and building these training clusters. So that's a apolitical category of, system design. Then you go into inferencing, and that is usually a much smaller problem. Now we have very large models and they don't fit on a single GPU, but often, you're on like maybe 8, like kind of on the maximum. If you have a really, really large model, which is not necessarily what you're using to do inferencing to an end customer, but maybe for model verification for yourself, then you may go to 16 GPUs. So let's say 2 boxes, but you're not going much beyond that. And so if you now look from a consumption perspective, training this, we talked a lot about these huge training machines, but in the end, when you're scaling it to consumers, like the ratios of consumer hardware or consumer consumption capacity you need to put down is orders of, or at least an order of magnitude larger, right? And at the very beginning, all the investment went into training because we need to make the model. Now we have the model. Now we want to use it, and now the growth actually happens on the inferencing side. So it's a natural conclusion from an OpenAI perspective to control your destiny. Now the easiest one is you read the profit statements of NVIDIA, and they're around 69. Well, like 68 and 69%. And so if you want to get they're doing well, and it shows in the stock price. So if you want to take a larger chunk of that revenue and of the profits, then you partner with a chip manufacturer, you get an exclusive deal. I'm sure like NVIDIA and OpenAI, they have very specific deals where OpenAI probably pays less than the rest of the world, but still, it's if you can control your supply chain for the product you're building one step further down, or two steps further down. The first step is like, okay, I own my data center. The second step is I control the chip. Now you can actually do chip manufacturing, and you can design a chip for your protocol models, and you can co-design the model for the chip. And that's where you can probably get another 3-4x in cost reduction. And I think OpenAI now at that scale they're operating at are doing the natural thing of any company, which is control your cost.
Sure, but do you want to talk a little bit about how this might impact kind of like the market for AI services? Because it strikes me that in the past, the way we've sold AI is that we go to customers and we say, look at this brand new shiny model, look at all the things that it can do, work with us. And presumably part of the pitch that OpenAI has here in the future will be, well, it's also running on our chips. And as a result, things are way faster or like way more performant. And kind of curious if you think that's going to shape sort of the sales pitch in this space, like sort of moving from selling the underlying infrastructure to like being the kind of primary focus versus the model per se, which I think we're seeing is just becoming more and more open source.
Yeah, absolutely. And TSMC, for the people who don't know, is the 100-pound gorilla. Like they have like 65% plus of the market.
100,000-pound gorilla.
100,000 pounds. Like, the world comes to a grinding halt if something happens to TSMC. And we're talking about chips. My Tesla door handle has 2 sensors, right? Imagine thousands of sensors across the entire car. All of those are being coming in from TSMC. Outside of Samsung, I don't think there's any other brand that comes even more than 10% of the marketplace. So TSMC is super critical. Everybody's designing the chips, but TSMC is the heart of the entire industry at this point. Now, if you look at Amazon, that's a good analogy. Amazon has its own inference chips. They have built their own Nova models that are super optimized for their own chips. So that combination, Anthropic is going to be using a lot of the Amazon chips as well. So when you optimize the architecture of the hardware to work with the architecture of the software itself, that does magic. The total cost and the throughput that you can get, the latency decreases, the cost of delivering that comes down significantly. So in the enterprise world, when we go do these large projects with clients, you're looking at high volume use cases. So for example, if I take a Llama model, the Llama 3 model could be running on Azure AWS. It could be running on NVIDIA. It could be running on Watson. When you look at the inference stack, if you take that Llama model and you make a NIMS out of it and you put it on NVIDIA directly, that is particular now for that particular model, they have NIMified it. It's going to run at 5x more throughput. You may pay 5% more extra cost, but now you have 5x more throughput. So that brings up use cases where you're doing some inferences at massive scale. So as an example, if you're doing, say, fraud detection, and you're looking at an invoice coming in, or you have an image that you're looking at, and you want to do that today at scale. We have been using classical computing techniques for doing those today because the volume is very high. You need a very quick latency. You need to do this at millions of times every day. So the cost would add up really very quickly. So this whole shift towards Amazon inference stack with their own models, and NVIDIA with NIMS on top, this is the trend that OpenAI is following as well. So that high volume use cases, the cost of doing this would go down and be very effectively running in production at scale. So from an enterprise perspective, the use cases don't change. But now we start to go after the high volume ones where earlier the ROI didn't exist. So I'm generally very excited about people looking at inference and optimizing it so I can take more AI to my clients and infuse that into more processes at scale and deliver high ROI.
Yeah, for sure. Kate, do you think one thing that kind of occurs to me is do these structural changes create any like dangers, I think, for open source? So kind of what I'm thinking a little bit about is in a world where you've got models, but they run way better if you're using a particular kind of hardware, or they can only run on a particular kind of hardware. It actually changes kind of the dynamics of open source, where I think the dream of open source is you can take your model, you can run it everywhere, and that builds the largest possible open source community around our models. Do you worry at all about kind of this hardware fragmentation as like things get more sort of specialized and kind of like really optimized for particular families of models?
I'm not sure that I worry so much. I mean, the model around open source has always been there are open source versions of technology, and then there are optimized enterprise supported versions that, end up being what gets deployed, right? And so we always need to have a bit of that balance as a whole. So, it's not something that immediately keeps me up at night. But I do think there's another really interesting thing that's going on here that, 80% of the reason why, NVIDIA is doing this is probably exactly what, Volkmar mentioned in terms of controlling costs. But I think there's an interesting part that also reflects that how these models are trained is changing. And we're seeing a much larger emphasis on techniques like reinforcement learning, which require a huge amount of inference of really big models. And so being able to control your inference costs no longer is just being able to serve your models at a lower cost point to customers and run larger and longer jobs. It also is now a critical part of training, so much so that you could easily start to see reinforcement learning costs starting to outweigh the cost of pre-training.
Yeah, that's wild to consider. I hadn't thought about that.
And I think, and Tim, this is in line with what Google has been doing forever, right? Their tensor processing units, the TPUs, are they're just so well designed. They do an amazing job at doing this distributed across multiple centers. They don't need to build one big cluster. They're able to do this in a distributed center and connect them with very high fiber optic cables to do inferencing at scale. They have multiple products that are billion users plus every day, right? They've been deploying these AI models, deep learning models, transformer-based models at scale at an insane pace across the world. So you will see more and more of this inference time, optimized models that are delivering great ROI and the right cost point. I'm very excited about the space.
Yeah, for sure. Yeah, I was also going to comment. I feel like MOE is one of the few podcasts you can go on where a panelist literally does the chef kiss for TPUs. I'm going to move us on to our next topic. There's a joke that I always used to make when I was kind of working at Google where we'd present, oh, this is AI. And when we say AI, there's lots of different techniques, but really what we're talking about is deep learning, right? And this was, a decade plus ago now. And I kind of feel like we've actually done a very similar thing now where we say, oh, well, when we say AI, we mean large language models. But it actually just turns out there's like lots and lots of things happening in AI. And I think one of the most interesting things that's been popping off lately is kind of competition over vision models, right? Which I think, have gotten short shrift, even though there's lots of exciting things happening there, but just because the LLMs have kind of taken up so much of the space. And Kay, ideal for you to be on the show for this episode, because I understand Granite is out with a number of new small vision models. And so first, do you want to kind of walk us through that and what's been launched? And then I kind of more generally want to talk about like how this space is evolving.
Absolutely. So a couple of things. First, VLM, a vision language model, it's a little bit different than what folks might be familiar with if they played with some of the earlier like stable diffusion models and a lot of the image generation models that we've seen to date. A VLM, which are these smaller models that are starting to get more popular, is all about image understanding. So it's an image and a prompt that gets sent as an input. Text is normally then returned as an output versus, some of the original really popular DALL-E and other models that you start with a prompt and you end up with an image. And the way these models work are you take a standard large language model often that's already trained to do language tasks, and you do some additional training and add a component on top that allows for an image to be, basically expressed as an embedding that gets fed to your language model in addition to the embedding from the prompt. And that information is together used from that language model to return the response. So these are really becoming popular. We just saw a bunch of models drop. Granite released 2 weeks ago our vision preview, and the full model is coming next week. So keep an eye out from the IBM Granite Hugging Face page. Our model is only 2 billion parameters. It's really small. You can run it locally. And what we're really excited about is we've taken a very specific approach focusing on document understanding tasks. So think of images from the perspective of a chart in a PDF or a poorly scanned PDF document, or a GUI or a dashboard where you like take a screenshot and put that into the chat box and start asking questions about it. So, Granite can do all sorts of general vision understanding tasks, but we've really optimized the performance around this document understanding. Thinking through from our enterprise customer perspective, that's going to be where there's a lot of really valuable use cases, particularly as we look at some of our other projects that are going on in this space, like Dockling, and more broadly looking at use cases around areas like multimodal RAG. So Granite preview released 2 weeks ago. The full version is coming out next week. We just saw Quen released, I think, earlier today or early last night. Their family of VLMs ranging from 3 billion to I think 72 billion parameters in size. And there's just a lot of other work going on in the space. Pixtral, for example, is a common one that's been out for a little while. And we expect to see this type of capability only grow.
Shobhit, do you want to give a little bit of a picture of kind of how the competition around this is evolving? I think, again, it's kind of like, almost like a little bit like deep research, right? Which is, well, we've got this kind of interesting use case, and now people are trying to figure out where in the market it really belongs. For VLMs, it also seems similar, right? Which is like suddenly you have this class of small vision models. What are enterprise people wanting to use it for?
No, absolutely. We've been working on vision models with clients for a while now. Earlier, this was a lot of the heavy lifting used to be done on a server on the cloud. So for example, if I take a Gemini 1.5 Pro model, it just chews through a whole video and can understand exactly what happened and has a really good understanding of what's going on. Those were very big, large models. There are a lot of use cases that we've been delivering for clients. As an example, large consumer goods company, distribution company, you have things around planograms where you walk into a store and you want to make sure the shelf has everything the right way. There are consumer goods companies where the label behind a particular product has to be regulatory compliant to each region, right? If it's food versus some dresses and stuff. Then there are certain use cases around describing what's in the catalog. So for example, a large electronics manufacturer or a clothing apparel company or retailer, they would take images of what people are trying to sell. So when you upload a product, you want to describe that product. If you look at a big furniture store, when you take a piece of furniture, you need to create a lot of metadata so that it shows up in the research and stuff, right? Usually all of those tasks were very human-driven. Now we're at a point where the images, as Kate was saying, they have evolved quite a bit, the VLMs, and they have a better understanding. Earlier, they were able to just identify what's in this particular image. Right? I could do some correlations and say, this looks like a cat, this looks like a dog. Now it has evolved quite a bit. So for example, one of my clients, we have a camera that points at all the counters, and you can see and tell which counter is more busy because it's also doing a people counting on the fly, right? So it understands which product is getting more popular. It has a better understanding of temporal. If I give you a few screenshots or video, it understands what's happening in the video, right? So from frame 2 to frame 19, what changed delta? So it's trying to understand that even better. So OCR was the first wave of use cases that we found. Now we're getting into more and more semantic understanding of what's happening in the overall picture. That starts unlocking even more use cases. And to Kate's point, the models are getting much, much smaller now. That allows us to do two things. One, I can now run these on a device while the person is running around. So the person in the field, in a manufacturing facility, can take a picture of something, can have a small camera that's running, and things are running on device. This was supremely important for security. A lot of these use cases, you don't want the images to be streamed out for security reasons. You want to run these things near on-prem. We're looking at defense use cases, drones running around in territories where you don't have control over the cellular network and stuff like that. All of those required us to do smaller models on the edge. The second category of things it's unlocking for us is high volume use cases. So for example, the document processing that Kate mentioned, those are being done millions of times every day. The incremental cost difference between a 7 billion parameter model and a 15 or 30 billion parameter makes a difference to the end ROI of that use case. So we're now coming to a point where these small models deployed either at scale or on device are delivering the ROI that's so critical for us.
Yeah, that's great. Volkmar, I'm going to give you an impossible question for this segment to close out this segment. To what Shobhit just said, right? There's these very interesting kind of pressures. And I don't think there is a clear answer just yet as to like how much of AI workloads will happen at the edge versus in big data centers. But it does feel like kind of like the prominence of smaller models and the fact that they're actually like perfectly performant for most industrial tasks means that we have a world where this is going to be more and more on the edge. But I don't know if you think like the trend is really going to be sort of 50-50 when this all kind of settles out. It's going to be all mostly on the edge, or just kind of curious about how you size up like where you think the models will live ultimately.
Mm-hmm. So I think it will be a bit of everything from a bandwidth perspective, right? It's very cheap to transmit a couple of words. It's a very, very low bandwidth channel. The moment you go into vision, that's a high bandwidth channel. So you have a bandwidth issue. And so this is traditionally, if you look at computation, it always has been this trade-off between, do I bring the computation to where the data is, or do I bring the data where the computation is? And so I think with text, maybe ignoring latency, it was kind of in favor of bringing it to a data center so you can do the consolidation. It's like the argument of, should I have a nuclear power plant or should I have a generator in my backyard, right? And so I think we have the same, nuclear power plant in the end, because you get consolidation, is more efficient. But now I need to have a power distribution network. And so I think we are in a similar situation here where if I have a high bandwidth stream and I can actually solve this with a relatively small model at the edge, that the economics work in that favor. And if you look at the trend, we are now making decisions on the complexity of the question. Now for videos, that's really hard. But if you look at what the iPhone did, and we will see this probably in all the phone manufacturers, you have a model router at the beginning, and the model router decides this is an easy question or a complex question. If it's an easy question, I stay on device. If it's complex, I offload it into the cloud. And so I think from now flipping this, the cheapest input device is effectively a camera, right? If you think about it, you capture 30 frames a second, and you have millions of data points, right? And so now the entropy of millions of data points over time is very low, but you can capture a lot of information in one shot. So the second one is audio. Would you want to transmit audio? That's probably more feasible. I think video is pushing it really to a point where you will just process on the edge. And then I think what will happen is that the models will specialize. So, what Shobhit said, you have these industrial use cases. And if you're on a manufacturing plant, you may want to keep it as a record, but there's no reason for you to move it, into a different data center in the cloud, because you already have industrial scale installations, you already have data centers, et cetera. And so it makes much more sense to just do it, locally. Now, locally does not necessarily mean inside of the camera. That may be required, if you have a battery or so, but it could be inside of a building and, may run a cable which is a couple of 100 feet long.
Yeah, that's right. Yeah, it's a good reminder that like where the edge is totally dependent on where you are. So,
and we kind of have this natural, tendency, because everybody carries an iPhone around, that it's the phone, right? And so, it needs to be a package of a battery, a camera, and a processor, but that's not necessarily true.
Maybe just a final question, I guess, Kate, if folks want to learn more about Granite's work, where should they go to get this new model? I know you said that there's a big announcement and there'll be a release next week, but anywhere, online people should be paying attention to or anything like that?
Yeah, I mean, we always post everything on our Hugging Face page under the IBM Granite org, and then encourage folks to check out ibm.com/Granite, and you'll be able to find all the latest there.
I'm going to move us on to our last story of the day, really kind of more of a publicity stunt, if I can say that up front, more than anything else. But I think it is kind of an interesting set of questions. The story is that Firecrawl, a Y Combinator startup, so very, very early company, got a little bit of attention on social media because they put out a job description. The job description was basically looking for someone who could assist in their open web crawler business. But the kind of listing specifically said, humans need not apply. This is only for AI agents. And on interview, the founders of the company admitted, right, like this is just kind of conceptual. It's kind of a funny experiment. This is sort of a publicity stunt more than anything else. But it did get me sort of thinking about, how far agents are going to go, particularly in the next year or so, and whether or not for certain types of tasks we really will start seeing kind of call for agents, right, to basically say, well, I could hire a human to do this job, or I've got an open call if anyone wants to produce an agent that will do the same job. And so maybe, Kay, I'll throw it to you first, is like, are we living in that world? Are agents getting good enough, fast enough that, we're going to start to see in 2025, 2026, some jobs really have listings for agents specifically?
Well, look, I think what they did was clearly a bit of marketing tongue in cheek. But I think it's very realistic that to have a near future where we have catalogs of agents and people can also create, specs for agents that types of behaviors that they want so others can build it and sell those agents, right? I think that's very much where we're headed. I don't know that it's going to be a total job replacement, so to speak. I see a lot of opportunity for agents augmenting human roles and jobs, and I think that's much more realistic of as we look at like what will a job description look like next year. Having expertise and familiarity, and part of the job description is helping manage agents and work with AI systems, is I think going to be increasingly a huge part of the new workforce, so to speak.
Yeah, I think that'll be sort of an interesting bit of it. It reminds me a little bit of back in the day where it's like, skills, Microsoft Office Suite, Excel, Word, whether or not kind of agents will be, or experience with agents will be kind of like a relevant skill.
Yeah, so I think this is not new. So if you look at what Dharmesh did from HubSpot CEO, he launched Agent.ai last year. It's the largest network where you can create, just like you would have gone to Fiverr to go hire people, you can go to Agent.ai and find a catalog people are rating, and you can hire that particular agent for a particular task, and you pay by different metrics, right? So I don't think this is new, having access to a variety of different agents who specialize in a particular domain. The way enterprises look at multi-agent workflows, we spent the last 5-10 years looking at structured directional flows. We would go into an organization and say, let me find the workflows that are yucky and I'll reverse engineer them. We'll all create a new way of doing it, and we'll codify it in a fixed flow. This was the RPA era. We got to only 10-15% of the flows that were deemed worthy of automation. The challenge there was when a human starts to trigger a flow, you go 5-6 steps in and you realize that, there was something that went wrong, and now you have to take over, and now you start from scratch. So the human expert would just rather go and do the whole 10 steps then by themselves, so they have more control over what's going on. So we could never go beyond 10-15% of the workflows that were automated using RPA, robotic process automation. In this agent world, we have an opportunity for not having to define every deterministic step. So within very thin guidelines and guardrails, an LLM can choose to figure out which API to call or which tool to choose and how to pass in the parameters and create some sort of a plan, iterate through it, and then make sure that we're heading towards the right direction. So very narrow task, those will get automated with LLM agents fairly rapidly. You will see this from the native companies, like Salesforce will have its own agent force, small pieces that are automated. But then you'll have external third-party tools like Azure has its own co-pilots, Watson Orchestrate and others that'll sit outside and they'll orchestrate work across a gamut of these different agents. The technology is solved, is maturing pretty rapidly. The thing that is missing in the enterprises is ask to task. I should probably trademark this, but humans are incredibly good at this. We go from an overall ask to a series of tasks in our head really well. As soon as I get a question about, hey, why is my bill higher than last month? In my head, I'll trigger a few different tasks. Today, as a human, I'm doing them in sequence. Tomorrow, as LLM agents, I can just trigger these off on our own. The companies who can create a golden thread of ask to task are the ones who will win in the space. The agents itself that are automating a small step, those will get commoditized really well. Once you have this golden record of ask to task, you can then create a planner agent that does that automatically for you. And that unlocks the multi-agent workflows then. In order to get to multi-agent, you have to solve for this ask to task. And the smaller LLM agents themselves, they will become fairly commoditized. And you'll be able to go to a network like Agent.ai and go find agents that are doing that small task really, really well.
Yeah, there's kind of a fun question here about sort of like effectively like what's the paradigm on which agents will get integrated into organizations. Like I think one of the reasons why, a job interview or a job listing for an agent is sort of silly is that, we have B2B SaaS. If like we want to use an agent, we just like, open up an account and click, 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 and we've integrated it into our system. I think the only kind of weird world that is opened up by some of the multi-agent stuff, there's this Google paper on AI scientists that came out yesterday, where essentially the paradigm was almost like we're going to have an agent that's the scientist, and then we're going to have some agents that run the experiment. And like basically the kind of model for integrating agents was to basically create like a one-to-one analogy with like a laboratory, and then have the agents put in. And that's the kind of world where you might want to hire. But I guess Kate and I guess Volkmar, you haven't spoken yet, but like we're not headed to that world.
It just makes me cringe. Like, this isn't preschool for agents, like there's got to be a better way.
Yeah, I think the APIs for that form of orchestration that is open, right? I mean, we went through centralized software to SaaS services, and you can just invoke an API. I think that is open how that would work. I want to give it a different angle. We have something similar right now, which is Mechanical Turk at AWS. Right, so I'm having micro tasks and I'm giving them out, and then someone processes it. So there's also an economic model of, do I have compute capacity available? And I'm not selling you a GPU, but I'm selling you the work product, and I may go to a centralized place picking up work items because I just have spare capacity, or I have a model which is specialized in a particular way which produces better results. So right now, this is more like a work queue management thing at a meta layer, like not saying, hey, produce me a bunch of tokens with Llama, but solve an actual problem for me and post a result. And so I think this is where it could go. And the other one is APIs. Like with the baby agents, you could orchestrate something, but for example, you may not have data access. So someone may, so let's say, I want to run a chemistry experiment. I may not have all the data which is required to run the chemistry experiment. So I could imagine that, I go to a company which actually sits on the data store, which it doesn't want to share, but is happy to share the results of research or the summarization of stuff. And then you may want to talk to an agent instead of talking to an API. So it's just effectively leveling it one up. So your interface to that data set may be the large language model.
So Tim, one of the things I'd like to highlight, just from a really hands-on keyboards perspective, when we're deploying these large multi-agent networks for our clients, and we've done quite a few of these in the last 6 months. A large pharma company, we're doing some content creation, authoring for compliance reporting, and there's another agent that will come audit it, so on and so forth. There's another healthcare client where we are working on a customer-facing member multi-agent where you can understand all other nuances and secondary intents that get triggered and come back. There's a telco where we're creating some software development. There's a BPO process where we're doing some 3-4-way matching. Quite a few of these examples where we have multi-agent frameworks in the last 5-6 months that we've put in production for clients. One of the challenges we're running in is, how do you describe the guidelines to these agents? We have, as a society, somehow figured out that English is the right way to talk to these LLM agents, which I don't think will scale in enterprises. When you get to agents, you're trying to go look at a complex workflow and saying that, hey, if you have a question about the status of the ticket, go use this tool. And you're giving it a few short learning. So the actual context that we give to these LLM agents becomes 2-3 pages for a small task, because you have to add all these bandages and if-then statements that essentially you're codifying in English. And that's just one small agent. When you start to get to the planner, this is completely breaks down. You cannot possibly give a 30-page context to a LLM. The latency is very high. There'll be all kinds of overlapping rules and things of that nature. So I think as a community, we will need to make some progress. And I think IBM Research is doing quite a bit in this space too, to get to a way in, like just the way Mechanical Turk works, we have a very structured contract between how you will go invoke a particular API or microservice or an agent. We'll need to get to a point where we have solved this for software engineering. We need to bring some of those principles. It will no longer, I think, be natural language in the way you go talk to these agents. There would have to be a little bit better software design principles that will need to be put in place for large scale enterprise deployments. So the hallucinations are lower, there's better auditability, evaluations and things of that nature.
Well, and I think there's two key points, right? It's like, how do I, as a developer working with an agent, express something in a very controllable, programmable fashion with very clear inputs and guarantees on the types of outputs I'm going to receive? And then when we talk about agents potentially passing information back and forth and other ways to compress information, reserve it, there's no reason that has to be natural language or that is even efficient in any sense of the word. And so, what is the most effective way to actually bring that communication, bridge some of that gaps? I really hate the nursery of agents all running around, each with their own persona of I'm a critic agent and I'm a reflection agent and I'm an email writing agent, and they all work together. Like, how do we set this up so it's much more of a program that gets operated, right? They're not people, they're not personas. There's instructions with very clear requirements. There's all sorts of agentic capabilities in this program, like reflection loops and validation loops and other things that happen, planning loops. But at the end of the day, it's a very clear program where information is passed from one program to another, and eventually a task is executed.
Yeah, it's almost like we've gotten so carried away by like the dream of the agent that we're like, oh, it's a little person. But like actually the optimal strategy is like, wait, is it just programming? Like we just have to specify very
where
clearly
our
what we
point
want
of
the software to do.
computer science is like we're saying, pretty please. I was looking at a prompt in an agent, and part of the prompt said, be persistent. Like, how is this how agent, like how the state of computer science has evolved to like, this is our programming instructions to a model. There has to be a better way.
Yeah, for sure. Well, great. Well, that's all the time we have today. Kate, Volkmar, Shobhit, thanks for joining us. And thanks to all you listeners. If you enjoyed what you heard, you can get us on Apple Podcasts, Spotify, and podcast platforms everywhere. And we will see you next week on Mixture of Experts.